Hello, we are Team RoverOva from VSB Technical University of Ostrava, and this is our rover, K3P4. Our team was formed at the end of 2016, and since 2018 we have participated 4 times in the European Rover Challenge and once in the Anatolian Rover Challenge, where we ended up at the 4th place last year. We meet twice a month to manage the tasks in our team. The work is organized through a Kanban board, with each team member responsible for a subset of tasks. We design our rover in Creo Parametric with its product lifecycle management tool Windchill, which allows all team members to have the current 3D models and documentation. Our workshop is equipped with 3D printers, a pedestal drill and handheld power tools. Therefore, to be able to produce parts in-house, the mechanical design is mostly focused on 3D printing or parts that do not require heavy machining. The rover's mobility system consists of an undercarriage with a rigid rocker suspension. The 4 wheels have integrated hub motors with planetary gearboxes. There are also 90-watt DC motors with planetary and worm gearboxes, which can steer the wheels individually, giving the rover the ability to drive using several configurations. We designed this suspension with rigidity in mind. Our 3D printed tires help the wheels get necessary traction and provide the rover with compliance to terrain. This, along with the rocker suspension, gives the rover good driving characteristics in terrain with relatively high maximum velocity. The mobility system without additional modules with 35 kilograms can traverse 20 centimeter high obstacles and drive on an incline of up to 40 degrees. The electronics in the rover are divided into 2 circuits, one for motors and the second for the logic components. An emergency stop button disconnects batteries from both circuits. At the heart of our rover is a Jetson Xavier NX computer, which communicates with various microcontrollers in additional modules. Power distribution boards and driver boards are custom designed and allow us to fit all necessary electronics even in tight spaces. The rover is equipped with a 6 degrees of freedom manipulator that was designed with 3D printing in mind. 2 of the joints are utilizing custom 3D printed cyclodal gearboxes that were thoroughly tested in our lab. We have tested the arm in various manipulation tasks. For example, here in our lab, the operators are controlling the arm to use the door handle, fully open the doors and drive through tight spaces. The arm is capable of grasping handles and pulling on drawers. The operator can utilize multiple ways of controlling the manipulator: direct teleoperation with an intuitive human-machine interface, or driving to safe positions, or using inverse kinematics to drive in various specific directions. With this capability, the arm can perform all of these manipulation tasks, for example grasping objects, delivering objects, turning screws and rotating valves. All of this while being observed by the operator with multiple camera views. There are several cameras on the manipulator and the end effector and the arm itself, for example FPV cameras, IP cameras or webcams. The arm is also capable of more fine control that allows for operating joysticks. The arm is also precise enough to insert a USB connector and to type on a keyboard. The arm itself weighs 9 kilograms and can grasp and carry objects of various sizes, weighing up to 5 kilograms, or pull heavier objects. We can combine the movement of the arm and the undercarriage to perform tasks that exceed the manipulator workspace. For example, putting a blanket on a human figure. During the science mission, we will collect soil samples to determine the suitability of human settlements in the vicinity and insides of lava tubes. The samples will also be tested for their chemical composition to find if they could be used for 3D printing Mars habitats. We have designed a laboratory module to perform preliminary tests. The module will deposit selected amount of soil into vials with reagents. A camera then observes the chemical reactions. Another set of tests will be done on the samples after they are retrieved by the team members. The laboratory module can also heat and boil the samples when necessary. The rover can be controlled with an 868 MHz RC transmitter or over Wi-Fi. If a signal from the RC transmitter is not available, the rover automatically switches to Wi-Fi. Video from IP cameras and webcams is transmitted over Wi-Fi. These cameras are high definition and capable of 4 times optical zoom. The Wi-Fi can, however, slow down the video transfer depending on the signal strength. That is why we have also implemented analog FPV cameras. The video from analog cameras is transmitted over 5.8 GHz band. Multiple analog FPV cameras with the video signal switch are used for low resolution but real-time feedback. With these systems, even if the rover loses Wi-Fi signal, we can still drive the rover with visual feedback, which allows us to finish missions even in environments without line-of-sight communication. The Wi-Fi and analog video have range of about 1 kilometer. The RC transmitter can control the rover to up to 10 kilometers. The cameras, along with real-time 3D visualization, provide good situational awareness for the rover operators. The autonomous navigation is implemented through ROS. The standard move-based package was customized for our needs, to work with our rover geometry and to perform the search for goalposts and gates. The localization relies on the fusion of visual and IMU odometry from Z2 camera, wheel odometry, and data from GPS module. The navigation algorithm is running on the rover itself and does not rely on the wireless connection to the operator station. Right now we are in the process of testing different search strategies in simulations and real field conditions. Once the rover reaches the desired coordinates, it will begin a search strategy to find the goalpost, attempt to drive near it, and display its current state with the lights on its mast. Our team is looking forward to competing once again in the European Rover Challenge. This international event brings together the brightest minds, and we're eager to showcase our latest innovations. We're excited to meet everyone in Poland and wish all participants the best of luck.